The aim of this video is to go full circle and look at all quadrants and come up with exact trig values, and that was an intended pun. Okay, so there's our unit circle, and we have what we call the common results. Okay, these are exact values, and we've got both degrees and radians, and we're going to see how do we generate such things. Exact values are the ones we do are based on 30, 45, 60, plus a couple of special cases like 0, pi on 2, pi, and 3 pi on 2. Okay, they're our special cases. So how do we generate all these? Well, remember, we know from our work with some triangles, isosceles and an equilateral, we've generated this table of values, which you should learn this table, okay? Because you want to be fluent, so learn. If you don't know it already, learn it. Be fluent. It's worth it, okay? And also remember that 2 pi radians is equivalent to 360 degrees. Do not be scared of radians, okay? Radians are not to be scared of. Don't be a radian wimp, alright? Unfortunately, there are some out there, and long term they keep getting scared all the time. You don't live like that. So embrace radians. Are actually a more logical way of angular determining angular measure. Alright, so with that in mind, let's look at some examples and how to do them. And just below, I've got some lined up. The first one there is cos 150. So we want to come up with the exact trig value for that. And we don't use a calculator. You may wish to do a sketch of a unit circle. And remember, we've done previous work on ASTC. Have you ever wondered why the radius arm is not ever negative? Have you ever thought about that? Now, there's a question I haven't answered yet, maybe in another video, but the radius arm is always considered to be positive quantity, and there's a reason for that, but there's no room in this video for that. So basically, we have our unit circle. 150 degrees is in the second quadrant, and it's 30 degrees before 180, so it's 180 take 30. And we've seen in our previous work that we use that acute angle there because it relates everything back to good old quadrant 1 where everything's hunky-dory. So they're the 4 angles that the acute angles we use, and they're commonly based on 30, 45 and 60. So what we do is we look at its cos, and this is the second quadrant. This is sines turf, so cos is going to be a negative. So it'll be negative of this acute angle here. So the acute angle is 30. So it'll be the same as negative of cos 30. So the negative of cos 30. Now cos 30, you should know all these values up here, but just to show you where they come from, there's cos 30, root 3 on 2. So it's going to be the negative of that root 3 on 2. So it's going to be negative root 3 on 2. Let's have a look at that circle above. Do you see the 150 there? That's what we were just using. Now negative root 3 on 2 is that first number there. Remember, all ordered pairs are x, comma, y, and remember from our previous work that cos relates to the x coordinate or the x value. So that's why that is negative root square root of 3 on 2. Okay. Next up we have negative 120 is the angle, and it's sine of negative 120. So remember, negative angles go clockwise. So we're going around clockwise, and the radius arm goes past 90 and it goes into quadrant 3, which is ASTC, because we've swung around here 90 and then another 30. What would the acute angle be here if that's 30? If that's 30 there, this would have to be 60 so the acute angle is 60. And being in tan's turf, sine is going to be negative, so it's going to be the negative of sine 60. Sine of 60 is root 3 on 2 from the table, so the answer will be negative root 3 on 2. Interesting that it's same answer as the one above. There is a reason for that. So if we look at the angle negative 120, or 60 below here, so 180 plus 60 is 240. So we're looking at that one there, and we were just working on sine. Sine is the y value, and so we did get negative root 3 on 2, so that's good. Next, 270 tan. Alright, now, actually I won't do that. I will change to red. Now, 270 is when the radius arm is pointing 3/4 of the way around. The angle is there. Tan, now, we are not in any particular quadrant. This is one of those special cases. So remember, tan is, from our previous work, tan theta is y over x. So the radius arm is pointing straight down. The x value, or the x coordinate, is 0. The y, because it's a unit circle, the y is 1, that's undefined. So that answer is undefined, and that's one of those asymptotes that we talked about, or places where tan is not defined, so it'll leave a gap when you plot the graph. Next, we've got sine of negative 7 pi on 6. So we're in radians now. Remember that 1 pi on 6 is 30 degrees, because 180 divided by 6 is 30. So we've got negative 7 pi on 6. That's going to go clockwise. So here we go. If we start here, how far is that? Well, that's more than pi, because negative 6 pi on 6, negative 6 pi on 6 is negative 1 pi, which is negative 180. So that means we're going to go past here, and then another pi on 6 that way. So that angle is pi on 6, and we are in S. So sine is positive, so this answer will be positive. So it'll be the same as sine of pi on 6, which is like sine of 30, which is a half. Let's check that answer. So we've got a half, and sine, remember, there's the angle, 5 pi on 6, because that's the same as negative 7 pi on 6, and sine is the y value, and that works. Alright, one last one. This one is a bit more advanced. Not only is it in radians, not only is it a negative angle, it's a big angle. Now, your 3 times tables, well, we have 3 times 8 is 24, and 3 times 9 is 27. So it's between 8 and 9. So that is a difficult one to think about. It's negative 8 and 1/3 pi. That's a big angle. Now, every time you go around 2 pi around this thing, that's a full rotation. So we've actually gone negative. So we've gone that way. We've gone 1, 2, 3, 4 times, and then we go another pi on 3, which is there. So that's the same angle as cos of negative pi on 3. So that's called coterminal, where you go around and around and you land in the same spot. It's like landing in the same spot as negative pi on 3. So it's the cos of negative pi on 3, and that puts us in the C quadrant. So cos is positive, so that'll be the same, because the little angle there is pi over 3. So we have the same as cos pi on 3, and that's a half. If some of those later ones were very tricky for you, by all means watch it again, watch that part of it again. Certainly the first few shouldn't be too tricky, so the first maybe 3 or 4 there should be quite doable. I would call for the class this video is pitched at, the last 2 would be more difficult. The last one's quite advanced, so that might take a bit longer, but you just follow the same steps for all of them, except for maybe ones like that one there where you have to use a little bit of different reasoning.